How would you like to have a robot that can do anything you ask it to do? A robot that can learn from different kinds of data and adapt to different situations. A robot that can use vision, language, and action to perform complex tasks. Sounds amazing, right? Google DeepMind works with many universities to make a big data collection of data and new model for robots. They want to make robots better at doing different things. They use data from 22 kinds of robots that can do more than 500 skills and 150,000 tasks. They want to make a huge online space where robots can learn and improve. They use new technologies like transformers and cross-modal learning to make the new model. The new model is very good at controlling robots, and it can help make robots smarter and faster in places like hospitals, homes, and factories. Google DeepMind and academic labs have joined forces to create the OpenX embodiment dataset, a huge repository of data from robots and 22 different robot types, enabling AI to learn from a wide range of data and perform well in different situations. The OpenX embodiment dataset allows robots to learn from varied experiences, sharing a common brain to enhance their ability to do various tasks, similar to how ImageNet transformed computer vision. Google DeepMind presents the RTX model, a combination of learning from different robotic data designed to give robots skills and adaptability to deal with a variety of tasks. The RTX models are a family of artificial intelligence systems that can control different types of robots and perform various tasks. They are based on the transformer architecture, which is also used for natural language processing and computer vision. The RTX models are trained on a large and diverse dataset called OpenX Embodiment, which contains data from 22 robot types, 500 skills, and 150,000 tasks. The RTX models can transfer their skills across different robots, environments, and tasks without requiring much retraining or fine-tuning. They can also use cross-modal learning to combine visual and linguistic information to perform novel tasks. The RTX models have shown remarkable results in comparison to specialized models that are tailored for each robot, task, and environment. The RTX models are considered AI supercomputers because they can handle complex and varied challenges in robotics, which could have applications in healthcare, smart homes, and industrial settings. Google is ready with another important thing for the improvement of robotics. Robotic Transformer 2, R2T, is a new vision language model, VLA model, that Google DeepMind introduced to improve robotic control with simple language commands. Using data from the web, RT2 wants to create robots that can skillfully move around human settings, similar to famous imaginary robot friends from sci-fi stories. Google DeepMind uses transformer AI models to make RT2 a model that can do many things with robots. The model is based on Google's previous AI models like PaLi-X and PaMi. RT2 also learns from data from RT1, an older model that was trained for 17 months. RT2 improves a VLM model with data from robots and the web, making a model that can see images from robots and decide what to do next. The model uses tokens like parts of words to represent actions and control the robot. This is the same way that RT1 did, but RT2 also changes actions into symbols. It likes strings to help the robot learn new skills. RT2 also uses chain of thought reasoning, which lets it make decisions with many steps, like choosing different tools or drinks depending on the situation. Tests show that RT2 is very good at doing new things, with a 62% success rate compared to RT1's 32%. But the models is not perfect. Web data helps understand concepts better, but it does not give the robot new physical skills that it has not tried before. Google knows these challenges and the long way to go, but hopefully RT2 is a big step towards making robots that can do almost anything. The OpenX embodiment dataset is a big collection of data from different robots. It is data from 22 kinds of robots that can do so many skills and tasks. Google DeepMind and many universities gathered the data. The dataset helps robots learn from each other and do better in different situations. The dataset is like a huge online space where robots can learn and improve. The dataset is the largest open source real robot dataset so far. It can help make robots smarter and more adaptable. Google DeepMind is a company that does artificial intelligence research and is part of Google. It started in the UK in 2010 and Google bought it in 2014. It has its main office in London and other offices in Canada, France, Germany, and the US. Google DeepMind has made models that use neural networks, which are like brains, that make cells to learn how to play video games and do humans things do, and neural tuning machines, which are neural networks that can use external memory like normal tuning machines. DeepMind Technology Limited is now doing business as Google DeepMind. Technology is limited in a British artificial intelligence research laboratory. It is working as a subsidiary of Google. It was founded in the year 2010 and is acquired by Google in 2014. DeepMind Technologies Limited has bases in London with research centres in Canada, France and the United States. In 2020, DeepMind made significant advances in protein folding with AlphaFold. DeepMind announced the development of DeepNash in July 2022. The DeepNash is a model-free multi-agent reinforcement learning system capable of playing the board game Stratego at the level of a human expert. In 2016, DeepMind named headlines after its AlphaGo program, which took a human professional Go player, Shay Seidel. He was a world champion in a 5-game match, and it became the subject of a documentary film. This competition between AI and human professionals revealed the power of AlphaGo, defeating the human player with ease. After Google acquired the DeepMind company, it established an artificial intelligence ethics board. The setting up of ethics board remains a mystery because with both Google and DeepMind at the top, they are not revealing who sits on the board. Google has been working for a long time on the new AI Gemini. Gemini is Google's new generation foundation model. It follows the path of Palm 2, the current AI model, behind the likes of Google's Bard chatbot and other recently announced features. Google Gemini is still in its training period and may be a powerful rival for ChatGPT. The Gemini AI was built to be multimodal and is with a focus on tool and API integrations. This will allow for wider collaborative efforts. Gemini AI is also being created to accommodate future developments such as improved planning and memory. The Gemini AI's most exciting and interesting feature is its ability to generate images and texts. Robotics has improved a lot since the 1960s and has helped manufacturing industry grow. Now there are about 3 million robots that work in different industries around the world, and about 400,000 new robots join them every year. They mostly work in the manufacturing industry to make things like cars, electronics and military gear. AI in robotics wants to make robots smarter and more automated. It uses techniques like computer vision, smart programming, and reinforcement learning to teach robots how to think and act like humans in changing situations. AI in robotics has done very well in many industries and has grown a lot in the market. The AI robotics market was US $6.9 billion in 2021 and is expected to be US $35.5 billion by 2026. The global pandemic made workers look for ways to work from home, making room for smart robots that can be set up and controlled from anywhere. Many organizations use AI robots in their regular work for more output, quality, and customer satisfaction. In both tech and non-tech industries, robots can be seen doing things like welcoming customers at shops, serving food at restaurants, picking crops, or moving heavy things at factories. Fruit harvesting is a hard and long work that farmers do every day. They need many weeks or months to harvest all the fields. Based on 2017 data, a worker would need 500 hours to pick apples from a field that is 38,000 acres and 2,550 hours to pick strawberries. Robots can use machines learning and computer vision to learn how to pick certain fruits. What makes the RTX model so powerful and versatile? Isn't it fantastic that they use transformer architecture and cross-modal learning to control robots of all kinds? What are the implications and challenges of creating such AI supercomputers? Comment your thoughts on this and don't forget to like, share, and subscribe.